Hi, my name is Rachel and I'm an engineer at Nevada Nano. Today I will demonstrate the MPS flammable gas sensor performance compared to a pellistor when exposed to a silicone-containing compound. Both sensors are calibrated to 50% LEL methane. The MPS is calibrated once in the factory and does not require recalibration for the full lifetime of the sensor. The pellistor was calibrated just prior to this demonstration. This test will demonstrate the MPS and pellistor response to a flammable gas after being subjected to a common silicone-containing compound. Silicone-containing products can poison catalytic sensors, causing their output to degrade over time and even become completely non-responsive. After poisoning, catalytic sensors give no indication of being poisoned, which puts the safety of the end user at risk. The pellistor in this test is a poison-resistant variant. These typically incorporate a filter to prevent poisons from reaching the sensing element. The MPS is inherently immune to poisons and doesn't use any such filters. This 38.5-liter chamber contains both sensor types and their evaluation electronics, as well as a small fan to mix the gas. The MPS is in the middle front of the chamber and the pellistor is to the right. At the top of the chamber is a balloon filled with methane. When popped, it will create a concentration of about 50% LEL inside the chamber. At the top of the chamber is a towel where we will spray some of the silicone-containing product after the balloon is popped. Now that the methane is evenly distributed in the chamber, I will spray in a silicone-containing substance and measure the response of each sensor. The methane concentration in the tank will allow us to see any response degradation from the poison. The solution I'm using today is a common vehicle detailing spray that the sensor could be exposed to if operated or left inside of a car, for example. This solution contains dimethicone, silicone polyether, and an organo-modified silicone. Other common silicone-containing sources that may affect catalytic type sensors are lotions, hair products, 3D printed materials, and sealing or gasket materials like caulking. Methane slowly leaches out of the chamber over the course of the test since it isn't perfectly airtight. After an hour and a half, the pellistor is reading 15% LEL while the MPS is reading 42% LEL. At 3 hours, the pellistor reads 0% LEL while the MPS is reading 40% LEL. Now I'll remove the lid to remove the poison. Both sensors have returned to reading 0% LEL now that they are back in clean air. A quick bump test with 50% LEL methane shows that the pellistor has been completely deactivated and doesn't respond to methane. This is due to a permanent reaction between the hot catalyst and the silicones, which has ruined the sensor. This creates a dangerous situation for an end user since the baseline may appear normal but will not respond to flammable gas. The MPS performs identically before and after exposure to silicones.